So I'm going to leave example 12 for you to do for study purposes, and we're going to go ahead and jump to example 13. So again, ordinary interest assumes 360 days a year. Exact interest assumes 365 days in a year, or 366 days in a leap year. So again, there are 4 different ways to compute it, and we're going to look at those 4 different ways in example 13, which is why we're jumping here. Okay, so here we have an amount of $4,650 is borrowed, so that tells us that it's our P. Goes at the beginning, and that's on January 22nd, and then it's repaid September 1st of the same year. Okay, so we don't need to worry about which year it is here. We want to figure out how much is needed to settle the debt, so that means we're trying to find S, and then all the possible combinations. And we're also told that our R is the 15%. So R would be 0.15, and then we're not told what type of percent we're getting, so again, that's going to be yearly. All right, so I'm going to work the different pieces in color, so that's why I'm doing everything in one color now that we have the basics down from section 1.1. Okay, so we're going to go ahead and we need to calculate the exact and approximate number of days, and then we can calculate the 4 different ways to do it. Okay, so let's look at the approximate number of days. So again, when we do approximate days, we're assuming that we have, I'm going to do this in green, we're assuming that we have exactly 360 days in a year, so exactly 30 days a month. Okay, so that means in January, if we're at day 22 and we're assuming 30 days, there are 8 days left. In February, there would be 30 days. March would have 30 days. April has 30 days. May has 30 days. June has 30 days. July has 30 days. August would have 30 days. And September, we have 1 day because we're ending on September 1st. Okay, so when we calculate that, we get 219 days. You could also do this as 8 plus 30 times 7, because we have 1, 2, 3, 4, 5, 6, 7 full months. Plus 1, that would work too. You still get 219. All right, now let's do the other one. We'll do this one in blue, so this is going to be the exact days. So I'm going to do the same thing. I'm going to write down all the letters of my months just to help me keep track of it. If you don't want to do that, you don't have to. I just think it really helps. So in January, we usually have 31 days. We're at day 22, so that means there's 9 left, so already we're bigger. But February only has 28 because we're going to assume not a leap year. March has 31. April has 30. May is 31. June is 30. July is 31. August has 31 days. And then September, again, we just have the 1 day. So when we add all of those up, we're going to get a bigger number, 222 days. So that it is different, but again, it's going to be really, really similar. They should be in the same ballpark, plus or minus maybe 5 days. If it's any more than that, then something went wrong and you need to go double check your counting. Alright, so again, to find S, we're going to use S equals P times 1 plus RT. Now we know R is 0.15 and we know P is $4,650. Okay, so again, the T is the thing that's going to change here. So let's do all 4. So let's do exact, ordinary. Okay, so that means that S would be 4650 times 1 plus 0.15. And then RT here, if we're doing exact we did in blue. So it's going to be 222. And then ordinary, we'll do in purple. So over 360. So again, same process as what we were doing before, just a bigger number. And this time our S is $5,080 and 13 cents. Okay. Let's do it again. So now let's do exact. Okay, exact. So we're going to start the same way. We're still finding S. Our P and our R have not changed, so we still have 4,650 times 1 plus 0.15, and then we have to figure out our T. So here when we do our T, exact day, so we're still doing 222, but this time it's going to be over 365 for our exact number of days, and again we're assuming not a leap year. And when we do that, we're going to get a slightly different number. This time we get 5,074 and 29 cents. Alright, now we're going to do it again. This time we're going to do it with approximate ordinary. So we start out the same way. 4,650 times 1 plus 0.15 times. And then here our numerator is our approximate number of days, so 219. And we're doing ordinary. So that's going to be over 360. So again, same setup, but our denominator is different and our numerator is different, so you need to be careful. So when we calculate that, we get 5,074 and 31 cents. Oh, this was supposed to be a 7. I apologize. Alright, let's do the last one. So this one is approximate exact. Same setup. S equals 4,650 times 1 plus 0.15. We're still doing our 219. But this time our denominator is 365 because we're doing the exact number of days in a year. So we get 5,068 and 50 cents. Okay, so all of these again are in the same ballpark, but we do have up to a $12 difference between approximate exact and the exact ordinary. So we do need to be careful when we're doing these problems. Now, banker's rule is the one that makes the most money. And usually, especially for loans, it's what the banks choose, which is why it's called banker's rule. So that is where we have exact time and ordinary interest. Okay, exact time and ordinary interest. Yes, honey? So that would be this one. Okay, and again, that's because it makes the bank the most money.